Hi everyone, in this video we're going to run through where your pipe sizing calculations are coming from when you are using the maximum velocity pipe sizing method. Okay, so the first video in this series is going to cover the heating system designs. Now the heating system designs use the kilowatt rating of the connected radiators combined with the flow and return temperatures of the connected heat source to determine the recirculation flow rate requirement for that pipe. Okay, so in this example, we've got four radiators, each one with 2.5 kilowatts attached to them, that connect back to a common loop running back to a heat pump. Before we get back to the heat pump, you have your domestic hot water cylinder, which has 5 kilowatts worth of load attached to that. And that's prioritized by this diverter valve here. So the greater of the loads from this direction and this direction will be put onto those primary pipes. Okay, to explain the mass flow rate calculation that H2X uses to calculate the flow rate requirement, we use the kilowatt rating of the connected emitters, and we also use the flow and return temperatures at the heat source, which can be found on the heat pump here in this example on the outlets tab. So we've got a flow temperature of 40 degrees and a return temperature of 35, giving a 5-degree delta T difference. Now, the specific heat capacity we use is around 4.2, but that does vary depending on the temperature of the water. In this example here, we're going to take the 5 kilowatts from these two connected radiators here, which will be on these connected pipes. And then we've also got the 4.2 specific heat capacity and the 5-degree delta T. Now, if we hit results, H2X is correctly going to tell us that the requirement on those pipes in terms of the recirculation flow rate is 0.24 litres per second. And you can see there that's based on a connected heat load of 5.07 and the flow and return temperatures of 40 and 35. The reason that the kilowatt load is slightly higher than the culmination of both of the emitters is that we have a setting on the heat pump turned on, and that setting is called include pipe heat load, which means that we're accounting for losses through the pipes. If you don't want to include that in your calculation, switch that to no, and then if we hit results again and we hover over that pipe, you can see that that goes to exactly 5 kilowatts, and we're still at that 0.24 litres per second figure because H2X rounds the value to two decimal places. So it might be 0.23875 or whichever. It might have gone slightly up or down that way. Okay, now if we move on to the next step, which is the pipe sizing selection, the flow rate can be used to determine the required area of a pipe. Now, that flow rate in litres per second needs to be converted to meters cubed per second. So that will translate to 0.00024 meters cubed per second. In the system settings, we've chosen to size to a maximum velocity of 1.5 meters per second. So using this equation here, we can determine the required area of that pipe, which is 0.00016 meters squared per second. And using some more in-depth maths, that will translate to a internal diameter requirement. That's the internal area, well, internal diameter of the pipe, not the external, of 14.27 millimeters. Now, if we go down onto our pipe breakdown here, these sizes can be seen in the system catalog, and I'll show you in a second when we jump into the system settings. But essentially, 15 millimeters external pipe diameter will translate to a 13.6 millimeter internal, and we've actually exceeded that in this situation, so we need to go to the next pipe size. 22 will result in a 20.2 millimeter internal diameter, and that is actually above our requirement here. So H2X, using the system setup, will specify a 22 millimeter diameter pipe using the maximum velocity setting in this situation. If we nip into the system settings, you can manipulate that sizing requirement by changing your maximum velocity. So if we change this value to say 0.6, the reason I've gone so low is I've tested this out and we need to go to around that figure to get a change in pipe size. whilst we're here, I'll show you that you can alter the available pipe sizes in your catalogue. So you can say whether you can use 10 or 12 mil, or whether you want to keep certain sizes or remove certain sizes from that catalogue, and from H2X specifying them. You can also change your pipe material and your minimum pipe size that H2X will specify. So if you had a lower load, whether it would choose 12 mil or 10 mil, or if you wanted to stick to a minimum size of 15. If we go over to the catalogue and we go to pipes and we go to copper, you can see we've got a few different types of copper pipe. But if we keep on the BSEN 1057 and we click on the left portion of that graph, you'll be able to see the internal diameter values there for each of those pipes and other pressure information. If we go back to the project now and we look at the new pipe that we've been specified, H2X has now told us that the pipe with a 5 kilowatt heat load with a 5-degree delta T is now going to need a 28 millimeter diameter pipe based on a maximum velocity of 0.6 meters per second. Now, if we go back over to our calculations here, we can rerun these. So if we go on to here and we change 1.5 to 0.6, 0.00024 divided by 0.6. That will equal 4 to the power of minus 10. Sorry, 4 times by 10 to the power of minus 4, which would be 0.0004. This updated value would result in a diameter requirement of 22.6 millimeters. And you can see there that 22.6 millimeters for an internal diameter pipe will result in us needing to use the 28 millimeter external diameter, because we're above the 20.2 millimeter internal diameter for 22, but we're below the 28 millimeter internal diameter for which is 26.2. And yeah, that's an explanation of where the pipe size values are coming from and how you can manipulate them in different ways using the software. If you found this video useful, please feel free to give a thumbs up. And if you have any feedback or would like to ask any further questions, feel free to leave a comment. If you'd like to see more content like this, which kind of explains the software, how to use it, feel free to subscribe to the channel. Thank you very much.